Hello and welcome back to the series of Computer Subject Class 9, and we are studying Principles of Object-Oriented Programming, Chapter number 1, Lecture number 2. Now we would study about programming paradigms. Now it is an approach that is used to classify the programming language based on their features. Right now what we saw high level programming language, assembly level programming language, and machine level programming language. In the same way, we have programming paradigms that refers to an approach which is used to classify the programming language based on their features. In high level programming language, there are two types of programming paradigms. Paradigms is nothing but, so let's say for example, if we have a feature, right, we have two programming language 1, programming language 2. Both of them have different features. So what are we doing? We are just having their programming paradigms. Now when I say programming paradigms, at that moment what I mean is that it is a typical example where we have a pattern of something. I'm sure you would have confused it a little with different things. Let's consider this way. What happened that there someone developed programming language A. Okay. When we develop programming language A, it has features of A, it has features of B, it has features of C. Okay. Now there came someone else who developed programming language B. Okay. Now when this programming language B was developed, it had the feature of X, it had the feature of Y, it had the feature of Z, correct? So now what is happening? The statement says that when we are dividing the programming language based on their features, then that approach is called programming paradigms. This approach, whatever we just did, we divided the programming language into two parts, programming language 1, programming language 2, based on their features, whatever they had. This is known as programming paradigms. Now, based on that, we have two different features that are classified. One is procedure oriented programming, which is known as POP. Then there is object oriented programming, which is nothing but OOPS. Okay. We will first study about procedure oriented programming, and later object oriented programming we will study, because Java is an object oriented language, and that's how we will study it in the entire chapter of this book. But let's have a look at procedure oriented programming. Like you just saw, we had first generation language, second generation language, third generation language, fourth generation language, and fifth generation language. Right now we are using fourth and fifth generation language. In the same way, there used to be procedure oriented programming, but now most of the features have been shifted to object oriented programming because it has so many features. Let us also study about procedure oriented programming first. Procedure oriented programming is a model for beginners to learn programming. So it is a model where if you want to learn programming, you can first learn procedure oriented programming, in which we have a top down approach. This is very important. Always remember, we will study it later also. It is a top down approach. It mainly focus on the method rather than the data values. So this is very important. I would explain it more further, but let's carry on right now. Procedure programming skills splits the programming code into two parts. One is known as events or procedures, that are also known as functions or methods, which contains a series of steps or instructions that has to be carried out after one another. What does this mean? So they say, I'll erase this first quickly. Now, what they meant when they are saying the programming language being differed in procedure oriented programming is that now what's happening is we have sequence of features, let's say. Um, we have sequence of steps. We have sequence of step like add two variables. Okay. Then after adding two variables, you have to um, put it into some variable. Okay. Now after putting it to some variable, you have to print the sum variable. Okay. And then you have to, after printing the sum, you have to multiply the sum on its own. Okay. And then you have to print this sum square. So these are the steps that we want the computer to perform. Correct? So these are the steps that we want computer to perform. And what happens is that in procedure oriented programming, we go instruction by instruction. Means computer will first add two variables, number one, then it will go for sum is equal to, like it will initialize some variable, then it will print the sum variable, then it will multiply the sum variable, and it will print the sum square that we just calculated. So in procedure oriented programming, we go step by step. Okay. It is thus said, procedure oriented programming splits the program into code and procedure, into events and procedure, also known as functions or methods, which contain a series of steps of instructions that has to be carried out into one after the other. Why we say top down approach? Because we are moving from top to bottom. Understood? Okay. Then we have Fortin, COBOL, Basic. These are the examples of it. Okay. Now we will study about it, what are its principles. First of all, it is top-down approach. Second, it divides a large program into smaller program known as function or methods. This is very common. Like for example, I'll create a new one here. Let's say we were supposed to do some task. Usually it happens that any programmer, let's say if we are supposed to do some task, we have to do a add task, we have to do a subtraction task, we have to do a multiplication task, and then we have to do a division task. All of them have different codes in it, right? So what we do, we divide these functions, because what are these? These are functions only, right, for a program. So we divide them into functions, which we will later study what are those, but you can consider that these are the functions that we divide it on. And then these functions are what the procedure oriented programming is. Like it divides the very large program where we had so many lines into smaller programs. Basically, smaller programs like add is a program, subtract is a program, multiplication is a program, division is a program, all of them into small, small functions. And all these functions again become one program. Shall I give you one example? Okay. So let's say you had an egg tray. Okay. In that egg tray, you would have small, small eggs. Correct. Now what are those? Correct. So this egg tray is supposed to have some number of eggs in it, right? So what we did, we divided the protein into different small parts. So every day you can have one egg. So in the same way, you divide the entire thing, divide the whole protein of this egg tray into small pieces. Or you can also say, when your mama prepares dal at home, she puts that dal into different bowls, correct, and give it to you. So what is she doing? She is dividing the entire food among the family members. All together, you guys are called as family. But inside family, there are father, there are mothers, there are son, daughters, and so on. So son, daughter, father, mother, all of them becomes function, and the entire family becomes a program. Understood? It is a step-by-step execution. That means step by step we will go from one step to the another. I showed it. I showed that to you here. Then we have advantages of procedure-oriented programming. They are very reliable and are tested algorithms. Program flow is very easy and is easy to understand. A smaller amount of memory is required as compared to other programming language. It uses functions. The program can be executed on different type of processors. Disadvantage: these methods are shared globally. Hence, more debugging is required in the program where the method is used. Why do we say so? Let's say, for example, you did a mistake in this add program. So, add program, there is a mistake that has come up. Okay. Now, this add program, we would have used somewhere in multiplication. Okay. What is happening? Or maybe to calculate salary, we would have used this um, you know, function, or to calculate fees, we would have used this function. Now, let's say, for example, we found the issue that the fees is not getting calculated correctly. If the fees is not getting calculated correctly, we would see the add function might be an issue. In that case, we would check if salary is working fine. If it is working fine, then that means there is no issue in add, because that means if one part of it is working, then there would be some problem with the fees function only. But if it is not working, then there would be an issue in add. So this kind of a long time would take. Right now I just take two functions, but there can be millions of functions when we go into the code. So it becomes very hard to debug that, okay, if there is an error, what to do and how to solve it. Right? So more finding errors is required in the program wherever they are used. So if we make a problem, if we make a issue in add function, it will block, salary will also not work, fees will also not work, and so many functions will be there in the code. It emphasizes more on the operation rather than the data. Thus, exposing the data to the entire source code, it reduces data security. Now, what happens is, to understand this line, let's take an example. This is our entire program. Consider this as our entire program. Okay. Now in this entire program, we have sub functions. Like one function is, let's say this one, another, I'll make it in another color so that it will be different. And then there is three functions here. Or maybe let's have four functions. Okay. Now these functions are responsible for any of the tasks they hold. Correct. One would be doing some task, another would be doing some other task, and so on. Now, let's say, for example, we are using a variable a and b. Okay, these two variables will be accessible to one function also because it has to add. Correct. Now, these two variables would be accessible to function 3 also because it has to subtract. Now, these two functions will be accessible to the second function because it has to multiply. Okay, and lastly, these two variables would be accessible to this divide function because it has to divide. Okay, the issue here is that since these variables are public as in all the functions can access it, all the functions can find the value. If by mistake we were supposed to give 1 and 2 as the value, by mistake I gave it as -1, then in that case, this add function will also go, it will give the wrong value, multiply will also go, subtraction will also go, and divide will also go. Or if there is a leak here, so maybe this divide function is not written properly, and whatever values that we have, it is giving to the some party, some different party. Let's say it is giving the data to Google or whatever. Okay, so it is putting up to Google or whatever. In that case, this becomes very difficult. So it it says that we have to do functions and we have to divide the data into more functions, which is correct. But at the same time, we should not expose our data. Variables are nothing but these are our data only, right? So if we should not expose our data publicly to the entire source code, because entire source code, all the functions can access it. This will reduce the data security. It is very hard to correlate it with the real world objects. So it is very hard to relate it with the real world examples that we have. Okay. Now we are starting a very important topic. If you are able to understand this, I am telling you, the entire chapter would be just a piece of cake. Okay, so we will start object-oriented programming. Object-oriented programming is just another way of programming. It is known as bottom-up approach. Now, remember we saw here that it was a top-to-bottom approach. Here it is written, it follows a top-to-bottom approach. Now, this one is a bottom-up approach. And it emphasizes on the data rather than functions. So right now we were focusing on the on the functions, but now we will focus more on the data. Okay. It splits the program into different number of entities known as objects. It increases the ability to deal with complex software problems, particularly for developing and maintaining large applications and data arrangements. Basically, you can say that it increases our chance to build large applications. You can just write it like that. Using this technique of writing source code and making it easy to create different objects from a common structure, this common structure is called a blueprint or a class, or the objects are created are known as instances. I'll create one thing. Okay. Now, let's say you are supposed to build a 2 BHK house. Okay. Now, when you are building a 2 BHK house, you would say that okay, or you can say you are building a 2 BHK society. Okay. In that society, from here it is the entrance. You have sofa here and the table. You have a dining table here. Okay. In that dining table, and then here it is your kitchen. Okay. And now there are one room here and another room here. Okay. Now in those rooms we have attached washroom. Perfect. And here is the balcony if you want to know. Okay. This is the balcony. Now the issue here is that right now you are just having one floor. Let's consider you are supposed to build 20 floors and it has the exact same map. Now, if you are having the structure, basically if you are having the outline of something, then it is known as blueprint. Why it is said as blueprint? Because it is a print of that particular surface which is lined as per its outline. Okay, this is known as, in computer language, it is known as blueprint of something. So this map is nothing but it is a blueprint. And if there is a blueprint of something, in object oriented programming, we call it a class. What do we call it? Class. Okay. If you will study this again, using this technique, when you're writing a source code, it becomes very easy to create objects from a common structure. This common structure, what we just created, this common structure is for all the 20 flats, right? One above the other. That is known as blueprint or a class. And the objects that are created are known as instances. Now you would ask me, what are objects in this? Right? So this was the building, okay, and it had 20 floors. Correct? It had 20 floors. Now every floor is one object. Understood? So one object is nothing but every floor. So there are 20 objects. of one class, one blueprint. Okay. Let us take some different examples so that you are able to relate. We all are human beings, correct? So, human beings are one class. Every person is one object. Understood? If you are still not able to understand, let me know in the comments. Now, Java, C, C++, Python, C hash are most common object-oriented programming language that are even known you still. Next, we have principles of object-oriented programming. I would come on advantages and disadvantages soon, but after the difference between the pop and oop, I will stop this video. I would then start with principles of object-oriented programming in detail in the next lecture, and then we would be completing this chapter. In the principles of object-oriented programming, we have data abstraction, inheritance, polymorphism, encapsulation. These are the four pillars of object-oriented programming. Just remember this as of now. We will come on to this later when we will detail study about it. Okay. Then we have advantages of object-oriented programming. Each and every instance means object. Object means a flat. Each and every flat has properties that are exclusively for its own and cannot be used by other instances. Someone who is living on second floor will not use something of first floor, right? Like the person who is living on second floor will not ask, hey, I want to use first floor kitchen. That does not happen. He would only use second floor kitchen, correct? So each and every instance has its own properties, and this cannot be used by other instances, other objects. For example, if you have a car blueprint, you can create instances of car. You can create as many as cars you want with different model names. That is totally up to you, such as Maruti Suzuki, Ford Figo, Ambassador, etc. Thus, a real world picture can be explained. Understood? It uses the concept of reusability, where the code is written once and can be used multiple times using different objects. So the map of the flat was done only once and we have used it 20 times. Right? Then reusability comes into picture. Maintaining the code, modifying the code becomes very easy. Then trying new objects with minor changes. So let's say if I have to make changes something in the map, I won't go to 220 different maps and correct it. I just need to correct it at one place and it will be corrected, and builders would understand that there is some change in the map. Okay, let's say for example, I don't want the bathroom here. I want the bathroom to be on this side, right? In that case, like if I make some changes, the builder would know and it would make all the changes in this 20 different objects. So maintaining and modifying the code becomes very easy. Abstraction and data hiding maintains the security of the data. This we would come again, and inheritance also we will come again. Why I'm leaving it? Because we would study it in the next page, in the next video, and I would be detailing it and I'll come back on this. Okay. Object-oriented programming. Object-oriented programming need more lines of code, obviously, because we have objects and class and so on. It needs, since there is more lines of code, we also need more memory because we have to execute it in high speed. If we do not have it, if we do not have memory, then its execution would be very low. It requires intensive testing because there are so many relations. Like we need to check if the class is working fine or not, if every floor is maintaining that particular map or not. So all these intensive testing would be required. Proper planning would also be required in this object-oriented programming. Now, what is the difference? In procedure-oriented programming, we divide the program into smaller functions, which is functions and method. Here, we divide the program into multiple objects. It uses top-down approach. It uses bottom-up approach. It deals with the algorithm Steps, it deals with the data. It is less secure. I remember I gave you an example of the variable being used everywhere, so it is very less secure. It is more secure. For example, C Fortran, for example, C++ and Java. We will be studying about principles of object-oriented programming in the next one, and soon the chapter would be finished. Thank you.